In modern naval warfare, the side that hears first wins first. That quiet reality is now shaping Australia's next move in the Indo-Pacific, and it's happening far from its own shores, in the waters around Guam, where the Royal Australian Air Force has just stepped into a far more demanding anti-submarine warfare training cycle under Exercise Sea Dragon 2026, deploying a P-8A Poseidon aircraft and around 50 personnel to operate alongside the United States, Japan, New Zealand, and India in a coordinated effort that goes well beyond routine drills and into something closer to a full spectrum rehearsal of undersea detection and tracking, because this is no longer about simply spotting a contact on a screen. It's about building a complete operational chain that can detect, classify, and continuously track a submerged platform across vast ocean spaces measured not in kilometres, but in thousands of nautical miles. And the choice of Guam is no coincidence. Positioned as a forward hub in the Western Pacific, it allows Australian crews to train in the same acoustic and operational conditions they would face in real-world scenarios to the north and northeast of Australia, where maritime approaches are increasingly complex and strategically contested. And what makes this deployment particularly significant is the shift in intensity. This is not a symbolic presence or a box-ticking exercise. It reflects a deliberate move by Canberra to prioritise real-world anti-submarine warfare proficiency, integrating advanced sensor networks, multi-platform coordination, and high-density sonobuoy deployment patterns that require precision, timing, and constant data fusion, all while operating within a multinational framework where interoperability is no longer optional, but essential. And in this environment, the P-8A Poseidon becomes more than just a patrol aircraft. It acts as a flying node in a distributed sensing network capable of processing acoustic signals, sharing data in real time, and maintaining a persistent picture of what lies beneath the surface, even when that picture is incomplete or deliberately obscured. And that is the core challenge being rehearsed here, not a visible confrontation, but a contest of detection, of information, of who can build a clearer understanding of the undersea domain before the other side even realises they have been found. And this is why Sea Dragon 2026 matters, because it signals a clear shift in how Australia is preparing for its strategic environment, not waiting for threats to approach its coastline, but pushing capability forward into the region, training alongside partners, and refining the skills needed to operate in one of the most demanding and least visible arenas of modern defence, where success is defined not by what is seen, but by what is quietly understood beneath the waves. What is unfolding around Guam is structured with a level of precision that reveals how modern anti-submarine warfare is actually conducted, not as isolated actions, but as a tightly linked sequence of tasks that must flow without interruption. Beginning with wide area search, where the P-8A Poseidon deploys a patterned field of sonobuoys across stretches of ocean that can span hundreds of square kilometres, each buoy acting as a listening node tuned to detect subtle acoustic signatures travelling through layers of water shaped by temperature and salinity. And from that moment, the crew is no longer simply observing, they are actively constructing an acoustic map of the environment, filtering background noise from biologic activity and shipping traffic to isolate signals that may indicate a submerged platform. And once a potential contact is detected, the process shifts immediately into classification, where operators analyse frequency patterns, propulsion noise, and movement behaviour to determine whether the contact is a diesel-electric submarine operating quietly on battery power or a nuclear-powered vessel with a different acoustic profile. And this is where the training intensity becomes clear, because the scenario does not pause for certainty. The crew must make decisions in real time with incomplete data while maintaining coordination with partner aircraft from the United States Navy, Japan Maritime Self-Defense Force, Indian Navy, and Royal New Zealand Air Force, all contributing their own sensors into a shared operational picture. And as the contact is refined, the mission transitions into tracking, which is widely regarded as the most demanding phase, because maintaining continuous awareness of a submerged target requires constant adjustment of sensor placement flight path, and data interpretation, especially when the target is maneuvering or exploiting environmental conditions to reduce detectability. And during Sea Dragon, the emphasis is on multi-static operations where multiple platforms transmit and receive acoustic signals simultaneously, dramatically increasing detection probability, but also increasing complexity, because every additional sensor adds both clarity and noise that must be managed, and throughout this entire sequence, the P-8A functions as a central node, integrating inputs, updating the tactical picture, and ensuring that no gap forms in the tracking chain. And while the exercise includes simulated engagement phases, the real objective is not the final action, but the integrity of the process leading up to it. Because in modern maritime operations, the decisive advantage comes from establishing and maintaining contact, not from a single moment. And this is why the shift in training intensity matters, because it reflects a transition from theoretical proficiency to operational readiness, where Australian crews are expected to perform within a multinational framework under realistic conditions, managing large volumes of data, coordinating across time zones and communication networks, and sustaining focus over extended periods measured in hours rather than minutes. And in that environment, success is defined by consistency, by the ability to detect early, classify accurately, and track continuously, even when the situation evolves faster than any single sensor can fully explain. At the center of this entire operation is the aircraft that makes the process possible, the Boeing P-8A Poseidon. And what becomes clear during these missions is that it is not simply a patrol platform, but a highly integrated system designed to manage one of the most complex sensing problems in modern defense. Because unlike surface or air targets, a submerged object does not reveal itself visually and does not emit a signal that is easy to isolate, which means the aircraft must rely on a layered approach that combines acoustic sensing, radar support, and continuous data processing to build a usable picture of what exists below the surface. And this begins with the deployment of sonobuoys, small sensor devices released in carefully calculated patterns across the ocean, each one drifting within a defined radius and transmitting acoustic data back to the aircraft, creating a distributed listening field that can cover hundreds of square miles. And inside the aircraft, the crew is faced with a constant stream of raw input, frequencies, pulses, background noise, and intermittent signatures that must be interpreted in real time, requiring both advanced software and human judgment working together, because no automated system alone can fully distinguish between environmental noise, commercial traffic, and a deliberately quiet submarine. And this is where the Poseidon's mission systems play a critical role, fusing multiple data sources into a single tactical display that allows operators to identify patterns as a track movement over time and maintain continuity even when the signal weakens or shifts. And beyond acoustic sensing, the aircraft also contributes through its surface search radar, which helps confirm the absence or presence of surface activity that might correlate with underwater movement, adding another layer of context to the analysis. And what defines the effectiveness of the P-8A in this environment is not any single capability, but the integration of all of them into a cohesive workflow that supports decision-making under pressure, where timing matters and delays can result in lost contact. And during Sea Dragon, this capability is pushed further through multinational integration, where data is not confined to a single aircraft, but shared across multiple platforms, requiring standardized communication protocols and precise coordination. And for the Australian crews, this represents a critical step in adapting to a networked operational model where success depends on how effectively information is shared and acted upon rather than who detects first. And in practical terms, this means that the Poseidon is functioning as both a sensor platform and a command node, managing inputs, directing adjustments to the search pattern, and ensuring that the tracking solution remains stable as conditions change. And this level of complexity explains why the current training cycle is more demanding, because it is not focused on isolated skills, but on sustaining performance across the entire mission duration, where fatigue, data overload, and environmental variability all combine to challenge consistency. And in that sense, the aircraft is only as effective as the crew operating it, which is why the emphasis here is on building proficiency that can hold under real-world conditions, not just in controlled scenarios, but in a dynamic and uncertain maritime environment where clarity is always partial and must be constantly refined. What makes this entire deployment more significant is not just the aircraft or the training cycle itself, but the location in which it is taking place, because operating out of Guam places these crews at a strategic crossroads of the Pacific, where distance, access, and timing all converge into a single operational advantage. And from this position, a maritime patrol aircraft can extend its reach across vast areas that include the Philippine Sea, key shipping lanes stretching toward East Asia, and the broader approaches that connect directly to the north and northeast of Australia. And this geographic reality changes the nature of training from theoretical to practical, because the acoustic conditions, traffic density, and environmental variables in this region are far closer to what crews would encounter in a real mission compared to operating closer to home. And that matters because underwater detection is highly sensitive to environmental factors such as temperature layers, ocean depth, and background noise, meaning that training in the wrong conditions can produce misleading confidence, while training in Guam forces crews to adapt to complexity that cannot be simplified. And beyond the physical environment, there is also the strategic function of Guam as a forward operating base for United States forces, equipped with infrastructure that supports sustained maritime and air operations, allowing for rapid sortie generation, extended mission durations, and continuous multinational coordination. And this creates an operational rhythm that mirrors real-world deployment patterns rather than isolated exercises. And for Australia, this exposure is critical because it aligns their forces with a broader network that includes not just regional partners, but also the logistical and command frameworks that would be activated during a larger contingency. And what emerges from this is a shift in perspective, where the focus is no longer limited to defending a coastline measured in miles, but expands into managing access across an entire maritime region that spans thousands of miles. And this is where the concept of forward presence becomes tangible. Because by training and operating from Guam, Australian crews are effectively extending their operational awareness outward, reducing the distance between detection and response and positioning themselves within a shared security architecture that emphasizes early identification and continuous monitoring. And in this context, Guam is not simply a convenient location. It is a deliberate choice that reflects how modern maritime strategy is evolving, where control is not defined by static boundaries, but by the ability to understand and influence activity across open ocean spaces. And that requires not only capable platforms and skilled crews, but also access to locations that enable sustained presence, coordinated operations, and rapid adaptation to changing conditions, all of which are being tested and refined in this environment, making the current training cycle a clear indicator that the focus has shifted from preparation within national borders to active integration within a broader operational system that extends far beyond them. What becomes increasingly clear at this stage is that this activity is not an isolated training evolution, but part of a broader shift in how Australia is structuring its maritime strategy, because the emphasis on sustained anti-submarine warfare proficiency signals a move away from passive monitoring toward active control of the undersea environment. And that shift is driven by the recognition that future maritime competition will be defined less by visible presence and more by who can maintain awareness beneath the surface over long distances and extended periods. And in practical terms, this means that the Royal Australian Air Force is aligning its capabilities with a doctrine that prioritises early detection, continuous tracking, and seamless coordination with allied forces, rather than relying on reactive measures closer to national waters. And this alignment is closely connected to the wider security framework that includes the partnership between Australia, the United Kingdom, and the United States, which is designed to enhance long-term undersea capabilities, including the future introduction of nuclear-powered submarines. And while that capability is still developing, the current focus on high-intensity anti-submarine warfare training serves as a foundational step, ensuring that personnel, procedures, and systems are already optimized for operating in a complex, networked environment. And this is particularly important because modern undersea operations are not conducted by a single platform or nation, but through integrated networks that require interoperability at every level, from communication protocols to tactical decision making. And the participation of multiple countries in this exercise reinforces that reality, demonstrating that coordination across different fleets and command structures is no longer an optional enhancement, but a core requirement. And beyond alliance integration, there is also a clear geographic priority, with attention directed toward the maritime approaches to the north and northeast of Australia, where critical sea lanes carry both commercial traffic and strategic movement. And maintaining awareness in these areas is essential not only for national security, but also for the stability of regional trade and logistics networks. And by extending training and operational presence into these zones, Australia is effectively increasing the distance at which it can identify and respond to potential challenges, reducing uncertainty and creating a more resilient security posture. And this approach reflects a broader understanding that control of maritime space is no longer defined by proximity alone, but by the ability to project sensing and decision-making capabilities across wide areas. And in that sense, the current training cycle is less about preparing for a specific scenario and more about building a persistent operational advantage, where information, coordination, and readiness combine to create a level of awareness that can be maintained even as conditions change. And this is what ultimately defines the significance of these activities, not as a temporary increase in training intensity, but as a clear indication that Australia is adapting its defence posture to meet the demands of a more complex and competitive maritime environment. As the training cycle continues to unfold, the broader implication becomes increasingly difficult to ignore, because what is being refined here is not just a set of skills, but a new standard for how maritime awareness is established and maintained across the Indo-Pacific. And at its core, this reflects a fundamental shift in how strategic advantage is defined, moving away from visible deployments and toward the persistent ability to detect, understand, and track activity in a domain that cannot be directly observed. And this is where the significance of these operations reaches beyond the exercise itself, because the combination of advanced platforms, integrated sensor networks, and multinational coordination is creating a framework where information becomes the primary currency of control. And in this environment, the side that can build the most accurate and continuous picture of the undersea space gains a decisive advantage without the need for overt action. And for Australia, this represents both a challenge and an opportunity, because maintaining such a capability requires sustained investment in technology, training, and partnerships. But it also provides a way to extend influence across a region defined by vast distances and complex dynamics. And what is particularly notable is how this approach reduces uncertainty, because by increasing the range and persistence of detection, it becomes possible to identify patterns of movement earlier, assess intent more effectively, and respond with greater confidence. And this has a stabilizing effect on the broader maritime environment, where transparency, even if partial, can help prevent miscalculation and maintain balance. And at the same time, it raises the threshold for any actor seeking to operate undetected, reinforcing the importance of adaptability and innovation on all sides. And within this context, the role of platforms like the P-8A Poseidon becomes even more critical, not as standalone assets, but as part of a larger ecosystem that connects air, surface, and subsurface elements into a unified operational picture. Yeah, and this ecosystem is what ultimately defines the future of maritime operations, where success is measured not by isolated actions, but by the ability to sustain awareness over time, across distance, and in coordination with others. And as these capabilities continue to evolve, the distinction between training and real-world readiness becomes increasingly narrow, because the conditions being replicated are already closely aligned with the realities of the operating environment. And this is why the current developments matter, not as a temporary adjustment, but as a clear indication that the rules governing maritime competition are changing, with greater emphasis on information dominance, network integration, and forward positioned awareness. And as that shift continues, the question is no longer whether these capabilities will shape the region, but how quickly they will redefine what it means to maintain security across one of the most strategically important bodies of water on the planet.